Yes, today we have to continue our usual discussion, our tutorial, and today we are going to treat algebraic expressions, algebraic expressions. Algebraic expression. When we talk of algebra, how do you understand it? Algebra. It is basically a representation of items using letters. Okay, that is, we use letters to represent certain items or certain components. How do I put it? Yes. For example, if a carpenter is having, let's say, 5 hammers, that you can write at 5 each, and then let's say 4 chisels and 4 like this. He can just do this representation that way. So when you see 5H plus 4C, it means it will be what? 5 hammers and then 4 what? Chisels. Exactly. Now, when we do it, you can use this to actually represent some stock of items, stock of tools in a shop or a specific place, you understand? So that is about the algebraic expressions. So we shall be treating several aspects of the algebraic expressions. We shall be dealing with expansion, the factorization, addition and subtraction, and simplification. That will definitely be helping you to solve a problem. And as I've already told you, or as I've already indicated, these classes that we are doing is basically more of a problem solving. So without wasting much time, I think we have to start with specific problems. Say simplify each of the following expressions. The first expression is 2a plus 3b minus 7b plus 4b. And we are asked to simplify this expression. How do you go about it? Basically, we have to understand that if you are having something like this, it's a matter of concentrating on the coefficient. So here, we are going to have 2a. Then, the coefficient here are what? We have 3b. So we have like this, 3b plus 4b minus 7b. Alright? So in that regard, working it out, we're going to get 2a, and here I think this one goes to 0, so the answer is 2a. The answer is what? 2a. I'm repeating. We are saying that we have 2a plus 3b minus 7b plus 4b. When you work it out, how many b's? We have 3 b's here. 3b plus 4b to do what? Here we let me simplify this way. This is 7b minus 7b. So here, this one will give you 7b. Alright? So then this one goes to 0. So it becomes 2a is our answer. Have you noted it? Now let's look at another example. Now we are talking about addition and subtraction of algebraic expressions. Later on, we shall be dealing with the expansion. Exactly. So let's look at another typical example. That is 6x plus y minus 10x plus 18 minus 5. And we are asked to simplify this. When you look at this carefully, you will see that we have 6x. That is, we have 6 as a coefficient attaching to what? To the x. Then we have y. Then we have 10x. Then we have 18. Then we have minus 5. So here you see that we are seeing about 3 different set of terms over here. That is, here we have 6x, okay, minus 10x. I'm looking all the x's first. Then followed by 1 plus y. Note that this is 1y. Okay. Then plus, in fact, 18 minus 5 will give you what? 13. Alright. 18 minus 5 is equal to 13. So when we work it out, what are we going to get? Here is what? 6x minus 10x plus 1y plus 13. So here, how do we get it? We are going to have what? Negative 4x plus y plus 13. Now, are you confused about this? Here, we are focusing on the coefficient here. If I have 6 minus 10, remember this is positive. Anytime positive and negative meet, right? Anytime you have positive and negative, then you have to subtract the smaller number from the greater number. So in this case, what is the greater number? What is the smaller number? The greater number is 10. I'm talking about the absolute value. The greater number is 10, and the smaller number is 6. So if I subtract 6 from 10, I'm going to get 4. Then I attach the sign of the greater number to the result. So the greater number result is 1. The greater number is 10. So the sign attaching to 10 is negative. Therefore, I have negative 4. Is that okay? Now, before we proceed or before we solve further problem, let's look at this. If I have, let's say, negative 2 minus 4, what is the answer? Negative 2 minus 4. This is more or less like integers. Negative 2, negative 4. It will give you, just add the numbers there. The numbers are what? 2 plus 4. That will be equal to 6. Okay, and the common sign is what? Negative. So I bring negative here. I'm repeating. Negative 2, negative 4 is what? It's negative 6. Let's look at another one. If I have negative 7, negative 2, negative 1. What is the answer? It is negative 2, negative. All of them are negatives. So I will just add the numbers. 7 plus 2 plus 1. That is what? 10. And the common sign is what? It's negative. So I just attach negative here. Is that okay? Okay. If that's the case, assuming the question were to be here, let's say A, and then A. Is that okay? Is everything alright? Okay, sure. So it is a matter of just attaching the A here. So once you know how to deal with the coefficient, then it is a matter of attaching this. Is that okay? Now, let's look at another one. So if I'm having, let's say, 20x minus 15x, what is the answer? Remember that here is positive. So positive and negative are paired. I'm talking about the coefficient here. So what is happening? We are going to subtract the 15 from 20, and that will give you 5, positive 5. Why? Because this was then I'll turn the x to it. Is that okay? Yes, that is how it is. Good. So let's look at another one which is very interesting. Okay. I'm having 5m plus 8k plus m minus 6m plus 9. And we are asked to simplify this. How do you simplify this? We have to simplify by trying to, group the terms. So no, here is, I think here is 4m. Okay. Now this is how it is. Here is 4m. So once again, I have to group the terms first. What do you see here? We are seeing a term that entails m, a term that entails a, and a constant. If I say constant, I'm talking about the numbers that are not having any letter attached to them. So if I want to group the like terms with this simplification, it's going to be 5m plus what? 4m minus 6m. Then you come to the k plus 8k plus 9. So as I've already indicated, here this and this will give you what? 9m, okay, minus 6m plus 8k plus 9. Please, you have to subscribe to Calendar Man TV, right? So, and we are doing the topic is algebraic expressions, and we are on addition and subtraction of algebraic expressions. Very soon we shall be dealing with the factorization. Is that okay? So over here we have what? There are a lot of topics that we are going to treat. So here is what? 3m, you are going to be plus 8k plus 9. Now, somebody will ask, so why didn't we add the 3 and then 8 and then the 9? The reason why we are not adding them is that 3m is different from 8k. Once the variable changes or it changes, you cannot add them. So you have to leave it as it is without it. So that is that. So I hope you are okay about what I'm talking about. There are a variety of them that we can talk about. Let's look at another example under the addition and subtraction of algebraic expression. We have 13 minus 16y plus 14 minus 25y plus c. This is another one that we are talking about. Now, carefully look at it. What do you see? You will see that we are having some letters and then the numbers. So I can say that here I can have 13 plus 14. It doesn't matter the order by which is the number side. Minus 16y minus 25y plus c. Is that okay? Now look at it. What do you get here? When you add it, you get 27. Okay? Now once again, this is what? Negative 16y, negative 25y. I think when you add it up, you are going to get negative 41y. Then plus c. That's all. You can't do any further simplification. I hope you are okay about that. So with this and many more. So use this typical example to solve variety of problems as far as this is concerned. So if you're okay, then I'm going to clean it a bit. We have to move to the next level, that is the expansion of algebraic expressions. Expansion of algebraic expressions. We want to expand, that means we want to some sort of multiply. Okay? So when we say expand, that is the thing has already been grouped and you want to expand it, you have to open it up. So let's give a typical example of expansion of algebraic expression. If I have, let's say, a plus b into bracket, then 2c plus 3d. We are asked to expand this. In certain books, they will just put this one a into bracket and they bring the whole of this 2c plus 3d. Then plus b into bracket, the same thing. 2c plus 3y. I'm repeating. We are asked to expand this. So I'll pick this a and multiply by the whole this. After that, I'll pick this b, multiply by the whole this. So that's what we are seeing. Now here, a times 2c. The number here is what? 2. Then I bring the a, I bring the c. Alright? Here becomes what? Plus 3ad. That's a times b. If you see ad, it means a times b. Alright? Then here, plus what? 2bc. Then plus what? Plus 3bd. Now, since none of them is common, you cannot add anything. You have to leave it like that as expansion. Exactly. Yes. So that is that. Let's look at another example, another typical example under the expansion of algebraic expressions. If I have, let's say, 4b, okay, minus 5b in brackets, then 5y minus d. Okay, I want to expand this. How do I expand? Just as I did in the previous example, I will have 4b into bracket, 5y minus d, then minus 5d into bracket, 5y minus d. We are expanding this. How do you expand it? I'm reminding you that you are watching Calendar Man TV and the topic is algebraic expressions. We have a lot of topics ahead of us that we'll be treating. Okay, so try as much as possible to subscribe to this very powerful channel because we're going to talk a lot about matrices, a lot of topics that will include technical awareness. Once you subscribe, you'll be able to get And remember that anytime you subscribe, the notification bell is very important. Something like the bell crying, you press on it and you move on. Now let's see how we're going to expand this. Here, I want to multiply this. So how do you go about it? Look at the numbers. You have 4 times 5. 4 5 is what? 20. Then the letters are what? V, Y. It's not difficult. 8 times 20 is what? The number is what? 4. So I have minus 4 VD or DV. Any of them goes. Then minus, look at it. You have 5 here, 5 here. That would be what? 25 dy. Then plus what? Plus 5d squared. Why is it 5d squared? Well, there's 1d here, 1d there. And why is it plus? Because when negative multiplies negative, it gives you positive. That's why I've indicated that way. Indicated it that way. That's how it is. Now you should know something. Anytime you are expanding an expression and it entails negative, let's say I have negative, let's say a plus negative a minus b, let's say plus c, something like this. And you want to open the bracket. In opening the bracket, we're going to have what? Negative a. The negative will affect the negative here, and it will what? Plus b, okay? Then minus c. What am I trying to say? It means that anytime there's negative sign here, it changes every term in the bracket. So here becomes negative a. Remember here was negative b. So it turns to what? Positive b. Here was positive c. It becomes negative c. I hope I guess I've made my point. Now, in fact, the area that I'm going to focus on so much is, I think expansion is not a difficulty, but we are going to talk about factorization of algebraic expressions. Factorization of what? Algebraic expressions. Factorization. Factorization of what? Algebraic expressions. The factorization. When we say you want to factorize something, what does that mean? You want to factorize it. It means the thing has been integrated and you want to actually break it into factors. You want to break it into, various, parts. It's just like if I'm having 20 and I want to break it into factors, then it's going to be what? It's going to be 20, that is 1, 2, 4, 5, 10, and 20. That is, I'm breaking it into factors. I'm trying to break it into smaller factors. So similarly, I may have an algebraic expression. As I've already told you, here this channel, it is more or less problem solving. So you want to look at problem 3, some of the algebraic expressions, example that we want to look at. Here, what we are doing is that as we solve, okay, as we continue to solve, then when you get it, you can apply it to solve variety different problems. So let's look at one of them. Look at it. Now let's say AC plus AB plus or minus C, okay, minus AY, something like this. And we are asked to factorize this, break this into factors. I think this is very simple. Why is it simple? Because we have A throughout, so that one is not a difficulty. How do you simplify it, or how do you break it? How do you factorize it? The common factor is what? Is A. I'll bring it like this. The question is, what am I supposed to write here? Here is going to be C. But the question is, how do you get this C? If your child in class 1 or whatever asks you, Daddy, how did you get this C? You should be able to complete the child beyond all reasonable doubt. Somebody will say that because it was A and C. The child will not understand it. So what we have to do is that tell him that this common factor. So here, I'm having AC over the common factor A. When you cancel, you get C here. I write my C. How do you get this? Here is going to be D. And how do you get to a D? The D, the same way I have AB here over this A, and that will be B. That's how we have B here. Now here, there is a minus sign. You have to be very, very careful. So here is what? Minus AY over A. A cancels A, you have negative y. That is why we have it that way. So this type of factorization is not actually a problem so much. But we shall be moving to an area where the terms are not all that same. So from here, I will not spend much time here. But I want us to look at an example. If I have 2AC minus AE plus 2BC minus DE. Carefully look at this. Carefully look at it. Look at it. What do you see? What do you see? You have a factorization of algebraic expressions. And I want you to carefully observe so that you see what I'm talking about. What do you see here? You know, here we have AC, AE, DC, DE. Here we have A and A here, but we don't have AC here. Likewise, here we have D here and D here, but we don't have D here. So they are not uniform, they are not throughout. So how do you go about it? If you decide to resort to the previous approach, where you are expecting that the common factor or common term should be running through, it is not like that here. Here you can see 2 here, 2 here, but you see, it's mixed, so you have to be very, very careful. So what you have to do is that in solving such a problem, we will not solve much, but in solving such a problem, first I will try and break this, the first part. When you spell the first part, what do you see? See, I have 2AC, then AE. Here, you can confidently know the common factor here. What is it? You have here to do what? A into brackets. So that's as I went about it. Here becomes what? Here is A, so we are left with what? 2C. Exactly, I'm repeating. This is an expression that entails about 4 terms. First term, second term, third term, fourth term. And we are asked to factorize it. So here, I'm having what? A is out and we have 2C here. Minus what? E. As I explained, when you divide, you get minus E here. Now, the secret is that after you do this, in the first place, you found the common factor here before you got the bracket. This time, come straight away here and repeat the bracket 2C minus E like this. That's what I'm saying. After you write 2C minus E, I'm repeating what is here over here. So now we are having the bracket before the common factor instead of the common factor before the bracket. I'm repeating for the last time. I broke this into 2. Then I took the first 2 terms. I inspected it and knew the common factor here to be what? 2. I brought this bracket. Here becomes easy like that. The moment you get this bracket, repeat the bracket under this second 2. After that, how do you write the common factor here? Look at it. You see that this one, it is directly under this. So I can say that 2DC, which is the one on the top, over 2C, the one on the down. I mean, this one, this first term in the second bracket corresponds to the third term here, or the first term in the 2 feet. If I want to cancel here, this goes like that. And here becomes my what? My D. Okay? Somebody can also use this to design. Is divided by that, you still get the 2. But remember that in algebraic expressions, try as much as possible to remember the sign. If you neglect the sign, you are in trouble. Now, look at what has happened now. You are having 2C minus B here, 2C minus B here. So they are common now. So the common items you have to write it once. So I'm going to have 2C minus B in one bracket. That is this and this. You write it once. Like twins, you don't count them once. Then, those that are outside the bracket should also move into one bracket. That is, you have A plus D. And that is the factorization. Okay, that is all about how we have factorized it. So, I want us to look at another example under that. Okay, I want us to look at another example. So let's look at another example, which is example 3. What is it? We have 2CD. You are watching Calendar Man TV. 6 cm plus dt, okay, minus 3mt. And we are asked to actually do what? We are asked to factorize it. So how do we go about it? Here, by inspection, you see that we are having the first two parts. We are having what? 2 over here. So in having the 2 here, what is common between the 2 and 6? We have 2 here, exactly. Now, then there's another thing common. I'm repeating. The number side, we have what? 2 and then 6. Exactly, I've written. What about the letter side? C is common. Note, even though you don't see 2 here, 2 can go into 6. That's what I want you to understand, okay? Then I bring my bracket here. What should I put here? I will just write 2CD. All over what? 2C. 2C cancels 2C. Here is what? My D. What about here? I'm having negative 6cm over 2c. C cancels C. This one cancels this one. Negative 3. So it becomes negative 3m. Negative 3m. Exactly. I put my bracket. After closing the bracket, then I'm going to write the common factor here first. That is D plus 3m. Exactly. So here, what is common here? What is common here? Let's look at it carefully. What do you think is going to be the common element here? If I'm having, here is minus. Here is minus. Okay. So if it is minus, then we can use this to divide this, and that will be what? T. So finally, I'm going to get D minus 3m into bracket. Then what? 2c plus t. Exactly. 2c plus t. Okay. Now, if you're okay here, let's look at a third example like this. Then, of course, we can proceed, because then you can use it to solve a variety of problems. Okay. Now, let us see another example under this. We are on algebraic expressions, factorization of what? Algebraic expressions. Okay, factorization of algebraic expressions. Let's look at another nice example. If I have 2 G3 plus GR plus 2G square K plus PR. It looks very, very interesting. Yeah, it looks very interesting, of course. Now, what do we do here? Let's look at if we can extract something common here. I think here we can have G is common here within it. Then here is what? 2G squared, right? Plus what? Plus R. Okay. Then here, you repeat this 2G squared plus R once again. How do I get this common factor? I can use last to last. So I can say KR over R, last to last, goes away. That will be K here. Or I can say 2G square K over 2G square. This one has, and still we get our K here, positive K. Okay. So here, the common factor in the bracket is what? 2G square plus R in bracket, then G plus K. And that's all. Exactly. So this and more are the factorization of what? The algebraic expressions. Okay. I think we can practice this to get more insight of this. So right now, I want us to revisit something. I think we've treated it before, but I want us to quickly look at that. Because very soon, we shall be moving to factorization of quadratic expressions, which is still under the algebraic. So let us try and get this very well, so that when it is time for us to do that, we can work on that. Exactly. So we are under factorization of what? algebraic expression, factorization of algebraic expression. Exactly. So you have to take note of that and then ensure that everything is clear for us. Okay, factorization of algebraic expressions. Let me try and think more a little bit because so that we'll be able to get a clearer picture of our presentation. Now, what does we represent factors of numbers? Factors of what? Not factors of no, factors of numbers, short form. That's why I've underlined it. Oh, it's factors of numbers, not factors of who. I hope you're getting it. Now, if I want to find factors of, let's say, 20, what are they? And how do you get them? You want to find a pair of factors of 20. How do you get them? You know we have integers or counting numbers, which is what? 1, 2, 3, 4, 5, 6, and so on and so forth. Okay. So if I want to get a pair of factors of 20, that is a factor is a number that can go into that number without a remainder. That's all. So look at what I'm going to do. What number are we finding 8 factors? It's 20. I'll just write 20 over the first one counting number is what? 1. That will be equal to what? 20. Exactly. That will be equal to 20. So over here, we write the number that went, so we have 1. This one, then I write my 20, which is the result. Repeating. We are finding factors of 20. So the first step is I pick the first counting number, which is 1 over 20, and I got the result of 20. Once I have got 20 here without a remainder, it means that 1 is a factor of 20. You want to look at the next set of factors. I will just write again 20 over 2. Second, and that gives me what? 10. Carefully observe this. Gives me 10. So I write this 2, and I write my what? My 10. Exactly. Now, if I go to 20 over 3, then we remember it will be 6.666. So I have to, any number that when you divide and there is a decimal, that number is not a factor. You have to skip over it and move on. So I'm having 20 over 4. Note that, watch here, see that 1 and 20, 2 and 10 are between these numbers. We are expecting the next factors to be between 2 and 10. So here I'm having what? 5. What did I use to divide? I use 4, so I wrote my 4 here, then the result 5. There's no number between here again. So the factors of 20 are what? 1, 2, 4, 5, 10, and 20. I want you to pay particular attention about this one. We are going to use it for a purpose. Do you understand? We're going to use it for a specific purpose. Now, let us look at another example of the factors. Okay. Let's check the factors of. You want to find factors of 60. Please pay attention. Factors of 60. So we have what? 60 over 1 is equal to what? 60. So I'm having 1 and 60. Exactly. We are treating algebraic expressions and we want to look at the factors. That will help us to actually do something and we move from there. Next one, what? 60 over 2. That will be what? 60 over 2 is what? It's 30. So I write my 2 and 30. Next one is 60 over 3. 20. Are you following? So I write my 3, I write my 20. 60 over 4. Look at the progressive manner. So we have 4 and 15. So look at the order. You see that as you move on, 2 and 3 is between 1 and 60. 3 and 20 is between 2 and 30. This and that. So we are closing, we are just closing. Then next one is what? Is 60 over 5 is 12. So we have 5 and 12. Okay. You have 5 and 12. You have 5 and 12. But I think we can proceed from here. Then you have 60 over 6. 60 over 6 is what? Is 10. So we have what? 6 and 10. Now in between here, 7 cannot go into 60, 8 cannot go into 60, 9 cannot go into 60. And then 10 that can go into 60, it has already been captured here. Therefore, you can write the factors of 60 if you want to write the factors. It's going to be what? 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Exactly. These are the information that we have about it. Now, having gotten this understanding, we can now start solving factorization of quadratic what? Expression. Factorization of what? Quadratic expressions. And I think after factorization of quadratic expressions, we can, this episode, we can and pick it from different lines. So factorization of what? Quadratic expression. Factorization of quadratic what? Expressions. When you talk of a quadratic, what does that mean? A quadratic equation, what does that mean? A quadratic equation is an equation that has a maximum power of a maximum exponent of 2. If I'm having something like equation the form ax squared plus bx plus c. This is a quadratic expression. For example, if I'm having 3x squared plus 4x plus 5. This is a quadratic expression. Why? Because the highest coefficient here is 2. Okay? If it was to be cubic, the highest coefficient would be what? Would be 3. So right now, I don't want to waste time. What we're going to do is that we are going to factorize certain quadratic expression very, very quickly and then move on and on and on. Okay? That is how it is. Okay? So, over here, let's look at a typical example of that factorization. And note that for quadratic expression, the term that's attaching the x squared is the a. The term attaching the x is the b. And then the constant is the c. So we say that factorize x squared plus 4x minus 21. We want to factorize this. Now, if you know this, it's going to help you a lot when we reach quadratics. But this one, if you get the first-hand information, if you are able to understand it from here, then that one becomes easier for you. Exactly. So carefully pay attention to what you are going to do and follow it aside. Note that anytime you see something here, there is nothing here, don't think here is 0. Here is 1. So the first step is to multiply a by the c. If I say a by the c, the first term here by the last term there. So I'm having 1 times negative 21. And that will be negative what? 21. In fact, I'm interested in the absolute value now, for now. Interested in the absolute value, which is the 21 now. Now, this is more or less a rough work. Yes. We are talking about factorization of what? Or algebraic quadratic what? Expressions under the algebraic. Okay? And we multiply this by this equals what? 1 times negative 21 is equal to what? Negative 21. That's the first step. But we are interested in the absolute value now, for now. Now, we want to list two factors of 21. Which one added or subtracted? It gives me the middle value here. Okay? But when you multiply, it gives you negative 21. Pay attention once again. You want to factorize this. The first step is pick the first term and the last term and multiply. First term is 1, last term is what? 21. So I multiplied it by this, I got negative 21. But for now, the interest is on the absolute 21. Okay, so as I told you, I'm having 21 over. So 21 or 1 and 21. That will be the first factors. When we add 1 and 21, what do I get? I got 22. Is that 22 here? No. Then let me subtract and see. I'll subtract 1 from 21, I got 20. Is that 20 in the middle here? No. So I move to the next factor, which is what? 21, 2 cannot go to, so 21 over 3 is 7. So I'm having 3 and what? 7. I hope you are getting it. What have we just done? 3 and 1, 7. Let's add 3 to 7, what do I get? 10. Is that 10 here? No. Then let us subtract the 3 from 7. If I'm having 7 and I subtract 3 from 8, what do I get? I get 4, right? I get 4. Therefore, this one will be more helpless. So I'm having 3 here, 7 here. Okay. Now, I want you to note something. If it is addition, then it is either plus plus, minus minus. But if it is subtraction, it will be plus minus minus plus. Let's get this better. The point is, what did we do before we got the 4? What did we do before we got the 4? I started listing the terms. And I did something before I got the 4. It is subtraction that gave me the 4. If it is subtraction, then it is either one of them should be positive or one should be negative. But if it is addition that gave me the result, then all of them should be either all positive or what? Or all negative. I believe as you progress, you understand it better. So here I'm having 3 and what? 7. If it is subtraction, then come and look at the sign here. The sign of the middle number here, this sign, and put it against the greater number. So here, the sign is what applies. So put it against the greater number here, then the smaller number becomes x, so that it becomes plus and minus, because it's subtraction. So if you want to be negative, I put negative before the greater number. If you want to be, let's say, negative 4x, then I put negative here, and then here becomes positive. What coefficient are we dealing with? What variable? We are dealing with variable x. So here is what? X and here is x. Look at this carefully. I'm repeating for the last time before I move on. We are asked to factorize this quadratic expression, okay? Now, in factorizing this quadratic expression, I'm saying that first we multiply the first by the last. So we multiply 1 by 21, and I got 21. It is absolute. Then I started listing factors of 21. So I got 1 and 21. I added, you add and you subtract. I added 21 and 1, and I got 22. And I checked here, that's 22 here. Then let us subtract and see. I subtracted this from this, and I got 20. Is that 20 here? So you have to move to the next factors of 21. 2 wouldn't work because 2 cannot go into 21. So I used what? I used 3, and then 3 is going to, and we got 3 and 7 as we did. After getting 3 and 7, then you ask yourself a question. Is it addition that gives the result of subtraction? If it's addition, then the 2 factors should be either all positive when the sign is here is positive, it will be minus minus. But if it is subtraction, then one will be positive and one will be negative. Which of them will be positive, which of them will be negative? You have to look at the sign here and put it against the greater number. So if here is negative, you put negative against the greater number. If here is positive, you put positive. I hope it's going one way, right? If here is positive, you put positive here. Exactly. Right now, what is the sign here? Now we've got 3 and 7. What is the sign here? The sign here is positive, so put the positive against the greater number. It is not the yardstick that always you put positive against the greater number. I'm saying that put the sign of this thing against the greater number, then the other one becomes the reverse. Okay? So right now I'm going to lift this and put it in place of the 4x. So I'm having 1x squared minus 3x plus 7x minus 21. I guess I've made my point. So now, this is what we've got now. I've transformed the equation to this level. So now we have reached where we started from. While we were simplifying ordinary, factorizing ordinary quadratic expression, algebraic expression. So now, I'm going to break this into two. Common factor here is what? X. We treated already, so I will not keep too long here. Here becomes what? X. Remember, minus 3. Then we repeat it, writing x minus 3 like this. Okay? Then here becomes what? 7. Oh, you remember, we divide it, because 7. Then here becomes what? X minus 3, which is common here, x plus 7. You have finished with your factorization. Exactly. I think it's very interesting. So, you'll be looking at other similar examples so that we move a lot of it as expected. We are on factorization of algebraic expressions, and to be precise, a quadratic one. When we say algebraic expressions, they normally don't involve equality sign in most cases. So that is how it is, but it's also a quadratic expression. Let's look at another one. We have y squared plus 7y minus 30. If you think that y will really confuse you as a new learner, let me use x for you. So that x squared like this. Okay. Now we are asked to factorize this expression. How do you factorize it? Remember that the sign here is 1. Okay. So I multiply 1 by the 30 and I got what? Negative 30. But I'm interested in the absolute values. And from what we went through, I can have 1 and 30. And check. When you add 1 to 30, what do you get? You get 31, right? But when you subtract, you got 21. Now, 29, none of them is portraying here. Let's check the next factors of 30. We have 2 and what? 15, exactly. 2 and 15. When we add 2 to 15, we go to a 17. Is that 17? No. When we subtract 2 from 17 and 15, we got what? 30. Is that 13? No. Then let's move on and see. What about 3 and 10? When I add 3 to 10, I get what? 13. Is that 13 here? No. What about later? When we subtract 3 from the 10, I got 7. It means 3 and 7 is going to solve the problem for us. Alright? Now that we suspected that 3 and 7 will work, what do you do? 3 and 7 will work. What are you supposed to do? We are now going to check 3 and 7 will give us that. But after getting this 3 and 7, we ask ourselves, what did we do? 3 and 10. You ask yourself, what did we do before we got the 3 and because we said that when we subtract, we got 7. So it means it is subtraction that is giving us the result. Alright? If it is subtraction that will give us the result, then still, once again, it should be 1 positive, 1 negative. So the sign here should carry the greater one. So here I still have my plus here, my minus here. And the sign is what? X here and X here. So I'm going to lift this thing here. It becomes this X squared will be maintained. Minus 3x plus 10x minus 30. Okay. This is what we are having now. So what is so common here? Here it is the same. This one is almost similar to the first one. So we have x here. Here is x minus 3. Then once again x minus 3. So what should we put here? Here is 10. Exactly. So the common factor is what? X minus 3 in bracket. X minus 3 in bracket. Then x what? X plus 10. All right. So that is that. Okay. So that is that. So let us see another example under this. Let's clean this and then see another wonderful example under this one. Exactly. We are on algebraic expressions. Factorization of algebraic expressions. Factorization of algebraic expressions. Factorization of algebraic what? Expressions. Now let us see another one. Let's see. We have 4x squared plus 17x plus 15. Alright? So once again, what do we do? Now that we've gotten the understanding, we multiply this by that. That is 4 by what? By 15. And we got our 60. Is that okay? So we begin to list our factors of 60. Now that, so here, you have 1 and 60. Will not give us 17 in no way. 2 and 30. When we add, we get 32, no 32 here. When we subtract, we get 20, no 20 here. 3 and what? 20. I think this 3 and 20 can help us. So 3 and 20 will help us. When we check it. When you add this to this, you got 23. So here. But when you subtract, you got what? You got what is it? You got 17, right? So the common factor here is what? Here, let me check. This plus here, and then minus here. But let's check it again because it looks as if over here, either there's something wrong somewhere. Or let's continue to check because though we are having 17 here, I'm wondering. Okay, let's check that because it looks as if there will be another factor that could, before we come back here, or there could be some time somewhere. Let's see. So let's check for 60. So we have 4. Let's check 4 and what? 15. Okay. Then we have 5 and 12. Have you seen that? I think 5 and 12 also. So over here, you know, I have a way of checking this thing. But right now, it looks as if, though 3 and 20 will be working. When you multiply back, you are not going to get your positive 60. So 5 and 12 will rather be the correct one to use. So here, you have 4 x squared. Since it is addition plus what? Plus 5x plus 12x plus what? 15. So the common factor here is what? X. So here becomes 4x plus 5. And here becomes, we repeat this one, 4x plus 5. So what is common here is 3. Okay. So I'm having 4x plus 5. Then x plus 3. So working it out. So the experience you have had here is that anytime you do this, and you are not certain, multiply back as if you got positive or whatever is here. You see, when we multiply this one, though when we sum it up, we got 17. When we multiply back, we will not get positive. Okay, so that's that. In fact, the moment you're able to understand quadratic from this point, this factorization from this point, and they ask you to define proof set, it's just a matter of like saying this is equal to this. Then you pick this 4x plus 5 is equal to 12. Then you solve. So we shall reach there. But the bottom line is that I want you to understand this basic concept, so that by so way it will be very well for us. Okay. Let's see if we can have another example, and that is here. It's very, very critical for us. So let's look at it now. I'm having. Let's see. I have 9x squared minus 6xy plus y squared. Look at this carefully. You see that this one is a combination of x and y. So in that case, in fact, it is similar to 9x squared minus 6x. It is similar to 9x squared minus 6x plus 1. It is similar to this. Look at it carefully. This one is here, and look at here. So we are going to follow that rule and then, be solving as such. So here, very soon we shall bring this to an end and then we continue from a different episode. Okay. Now, so here, you multiply this by this, and we go to what? 9 times 1 is equal to 9. And 2 factors of 9, that will give us 6. It's what? It's 3 and 3. Now, watch it. You see that the sign here is negative. And you sum them up before you got to this negative figure. So here, you have negative and negative. Okay? I'm repeating. I have negative 3, comma, negative 3. After multiplying. But watch it. Remember here, it's going to be xy, and here is also what? Xy. So look at what I'm going to put there. It's 9x squared minus 3xy minus 3xy again. Then plus y. What is going on here? 3x into bracket, another 3x. Minus what? Minus y. Okay. Then we do the same thing here. 3x minus 1. So here becomes what? Negative y. Sorry, minus y squared. So here we have a 3x minus y, then 3x minus y, which is a repeated expression. So I think that we have a pause here, and I'm asking you to subscribe to the Calendar Man TV. Okay, we shall be coming your way with a continuation of the algebraic expressions too, and that's where we dealing with the difference of two questions. We shall be solving certain specific. Subscribe to Calendar Man TV, and then you'll be getting it. There are a lot of topics that we are going to, treat. Thank you very much for your attention. Thank you.